Hello friends. So in this short video I'll try to demonstrate you that how we can form an image of an object using a convex lens, and how we can use this fact to see the focal spot of a laser beam. Okay, so this is my experimental setup, no explanations for that. So you can see this, we have a light source which is a white LED. It can be any source, and the light goes through the circular slit inside the chamber, and inside the chamber you can see I have placed a circular ruler. As you can see, the light goes through, enters the chamber, and it goes through, and inside I have placed a plastic ruler, a scale you can call. It has numbers written 1 to 3 centimeters. So the light passes through this ruler. So as you can see, inside the chamber we have another slit, the small circular slit or aperture. So the light passes through this aperture. As you can see, here is the aperture. The light passes through the aperture, goes inside the chamber, the bigger chamber, and here, as you can see, I have placed a double convex lens. The light comes out. I use a double convex lens to form the image of this ruler, the numbers written on this ruler, using a convex lens, and I'll try to see the image onto a screen. So the distance between the circular, the ruler and the convex lens is around 70 centimeters. So the focal length of this lens is around 30 centimeters, positive lens. And if you calculate, the real image will be formed on the other side, roughly at a distance of 50 centimeters. So the image should be formed, a real inverted image should be formed somewhere at a distance of 50 centimeters onto the other side of the lens. Okay, so I'll try to show you the image by projecting onto this white paper. So as you can see, as I move away, you can see the number, as you can see the number 6. I hope you can see. So you can clearly see the number 6. This is actually the image which is formed. This number 6 was written onto the ruler, and if I move the card away, I move away from the image plane. So somewhere here I do have a perfectly focused image. I hope you could see it clearly. So I'm going away, and as I come close, I do have the image. So I have switched off the lights for you, so clearly you can see the number 6. A very clear image is formed. This is a real image, inverted image, right? This is why you're able to see the image onto the screen. It is a real inverted image which is formed with the help of the double convex lens, right? Okay, so I have switched on the lights. I repeat, I have a light source, a plastic ruler with the numbers written on it. The light passes through inside the chamber, passes through the ruler, through the slit, goes through the chamber. The lens is used for the imaging, right? And the distance between the object, the ruler, and the lens is around 70 centimeter, and the image is formed on the other side roughly at a distance of 50 centimeters. Now, how we can use this fact in my setup? So as you can see, I have a laser beam which is going through the mirrors, getting reflected by the mirrors. This is a helium neon laser, okay, 632 nanometers, and finally the laser beam is getting focused with a convex mirror inside the chamber. So as you can see, somewhere here the beam is getting focused, right? So I'll try to image the focal spot similarly how I imaged the ruler. So the distance is same, the lens is same, and the image will be formed roughly at the same distance, around 50 centimeters. I have some filters. I have placed some filters in the path of the laser beam just to attenuate the laser beam, and I'll try to image the focal spot by using a camera, right? So I have switched off the lights. Here is the camera. I'll try to image. These are the filters just to reduce the laser intensity, the same lens. And this is the focal spot. You can clearly see the focal spot onto the screen, right? So here inside the laser beam is getting focused. So yeah, somewhere here in between the laser image is getting focused, and similarly like the ruler, the image is formed onto the other side at the same distance, and I've placed the camera on the image plane, and you can clearly see the image, the focal spot.